Alright, next thing we're going to learn is how to use the speed equation to solve problems. Remember that the speed equation is v equals d over t. That is, speed equals distance over time. And I'm just going to set up the three standard types of problems that you'll see and show you mathematically how to work them. The harder part of this that we're not going to go into as great a detail on is how to get the data out of the question. That is, the information might be in the question in such a way that you have to think about it. That will be something that's probably better worked on you and me personally face-to-face, looking at those problems and walking through how to get that information. So I'm going to save that for there. For now, let's just look at the nuts and bolts of this. So for my first example, what I'm going to say is, say we have a person that is walking home, and they walk a distance of, let's say, 5 miles, and they do it in 1.5 hours. So a nice leisurely pace. So 5 miles in 1.5 hours. And our task is to find their speed. So again, we want to find the speed of this person. Now the way we do this is we're going to set this up, and again, you have to set them up this way. I am going to force you to do this by not giving you credit if you don't do it this way. There are other ways, but I want you to show me that you can do this first. So first we write down what we're given. And again, this is the hard part. I've made this easier with how I've written this. But what you want to write down is all the numbers with units that they give you, and then tell what that is. So 5 miles is a distance. We have 1.5 hours. That's a time. We know this from multiple ways. First, I told you. Second, the units. Miles will always be a unit of distance. Hours will always be a unit of time. And you have to ask yourself, what is it we're looking for in this problem? What do we want? We want speed. And notice I'm using the abbreviation for speed, that lowercase v. It has to be lowercase. Uppercase means volume. Alright, now we have what we're given, a distance and a time, and we want speed. The thing that's going to allow us to find this, we want an equation that has v, d, and t in it. Lo and behold, that is the speed equation. So notice I'm writing the speed equation without doing anything else, just writing the equation. Now I'm going to substitute in what givens I know. I know the distance is 5 miles. I know the time is 1.5 hours. So my distance is 5. And my time is hours. And what I can do now is, notice that I wrote the units in there. It's kind of up to you. I'm not going to force you to write the units in there if you don't want to, but I will tell you it could be a very handy thing. Here's why. It will automatically tell you what the units for your answer should be simply by looking at the operations. But first, before we go any farther, to do the number part of this, all you do is take 5 divided by 1.5. You can ignore the units for that part. So 5 divided by 1.5 is 3.3 repeating. Miles divided by hours is just miles per hour. And notice that that is a unit of speed right there. And now we've solved our problem. We found the speed. It's 3.3 miles per hour. So that's how you would do it if you've got the distance and the time and you're wanting to find the speed. What if, however, that's not the situation? So let's look at a different example. And in this example, let's say that you have an object, whatever it is, traveling at a speed of 20 meters per second. And it does this for, let's say, 6 seconds. And we want to find the distance the object will travel. So we set this up just like we've set up anything else. What are we given? We're given 20 meters per second, which we know is a speed. We're given 6 seconds. Seconds, that's a unit of time. And we want to find the distance. And again, notice I'm using abbreviations there. We want an equation with v, t, and d. That would be our speed equation. Distance divided by time. And now I'm back to the point where I'm plugging in numbers. Now here's a case where I think plugging in the units might actually confuse you. You can if you want to, and I'll show you what that looks like down below, but for now let's go without them. Our speed is 20. Our distance we don't know, so we leave it as a variable, and our time is 6. Now in order to solve this, all I have to do is get that d by itself. Remember, that's the whole idea, is to find out what d is. So what I'm going to do is I'm going to undo whatever I've done to this d to get it by itself. And I've taken this d and divided by 6, so to undo that, I'm going to take the d and multiply it by 6. And so what I find when I multiply both sides of the equation by 6, because what you do to one side you have to do to the other, 20 times 6 is 120. The 6 cancels out from the bottom, and what I'm left with is d. So again, basically what I've done is I've said over here I was dividing by 6. To undo that, I'm going to multiply both sides by 6. That makes the 6 go away over here, and our distance is 120, but we have to add units to this. Well, what units of distance should we use? Well, if you look in your unit of speed, there's a unit of distance already there. The unit of distance is right at the top. So this must be 120 meters. Now if you wanted to do that with units, it would look like this. We get 20 meters per second equals d over 6 seconds. And when I multiply, I get 20 meters per second times 6 seconds. Notice what happens here is that the seconds on bottom cancel out with these seconds, and the only unit I'm left with is meters. Now that's kind of advanced. If you don't get that, don't worry about it. That's not such a big deal. But remember this, when my variable is on top, just multiply both sides by whatever is on the bottom, and that is going to get you your answer. All right, let's look at the final, potentially most confusing case. In example 3, let's suppose I have an object traveling at 10 meters per second, and it does this through a distance of 80 meters. We want to find the time it took to do this. And I've apparently done that off screen. There you go. So example 3, we're trying to find the time if this thing traveled 80 meters at a speed of 10 meters per second. You guys know the drill. Our givens, 10 meters per second is a speed. 80 meters is a distance. And we want to find time. So we use our equation, v equals d over t. We plug in what we know. 10 equals, in this case, d is 80 over t. And now we're left with the task of trying to find what t is. So what we're going to do, remember before, if we knew what was on top and we wanted to find what was on top, we'd multiply what's on bottom. We're actually going to take that same step again. Take what's on bottom and multiply both sides on it. Basically, you always want to avoid fractions. So we multiply both sides by t, and what we get is 10t equals 80. And now, it's pretty simple algebra from here. We've got 10 times t. We need to divide both sides by 10. And what we find is that the time is 8. Now we need units for it, so we look back at the units of speed. On the bottom we have seconds. So our time would be 8 seconds.